Here we're going to look at the oxidising ability of the halogens. Now, all the halogens are oxidising agents. They all have the potential to gain electrons according to the following half equation where X is any halogen. So all the halogens potentially can gain electrons to form halide ions. Now, the trend in oxidising ability of these halogens is something that you need to be aware of. And the ability to act as an oxidising agent decreases as you go down group 7. So we say oxidising ability decreases. And we can explain that because iodine is the largest atom. Therefore, it's got the weakest attraction to the electron that it wants to gain. This trend can be explained by looking at something called halogen displacement reactions. And with a halogen displacement reaction, what we react then is we react a halogen with a halide ion. So I'm going to call my halogen X2 and a halide ion which I'll call Y minus. Now, Y and X are both halogens, different halogens. In one case, the halogen has got an electron in the form of a halide ion. Now, if this reaction is to occur, then it occurs according to the following equation. So halogen X wants electrons. It wants to gain the electrons off halogen Y. And in doing so, X, if it does gain the electrons, becomes X minus ions. These halide ions, halogen Y loses its electrons to form Y2. Now, the key here is this reaction only occurs if X2 is a better oxidizing agent than Y2. And that is very, very important. That's the key to these halogen displacement reactions. The reaction will only occur if this halogen here wants the electrons more than this halogen. So let's have a look at a specific example. So an example would be the reaction between chlorine and bromide ions. And if this reaction was to occur, we would get 2Cl minus plus Br2. Well, does this reaction occur according to my statement here? As it said, this reaction occurs if X2 is a better oxidizing agent than Y2. X2 in this case is chlorine. And is chlorine a better oxidizing agent than bromine? Well, we can see here from the trend that oxidizing ability decreases as you go down the group. So chlorine is a better oxidizing agent than bromine. So that reaction there will happen. And it's a redox reaction where the chlorine is reduced to chloride ions. We've got oxidation state 0. then an oxidation state of -1. When the oxidation state reduces, goes down, it's reduction. And the bromide ions are oxidized to bromine. And again, oxidation, when oxidation occurs, the oxidation state will increase from -1 to 0. Now, based on the statement we've said here highlighted, we should be able to predict when a halogen displacement reactions occur. But we can also observe when halogen displacement reaction occurs as well by looking at observations during a reaction. And let's have a look then at all the possible halogen displacement reactions we could do. I will just state now that when we're looking at these reactions, you will not have to worry about fluorine in this. Fluorine is the best oxidizing agent, but when we're looking at the actual observations during the reactions, we will only be looking at these three. So let's have a look. We'll put the halogens going down, and just make a little note that chlorine solution, or chlorine water, is colourless. Bromine water is orange, and a solution of iodine is brown. I think it's iodine in dissolved in potassium iodide, which gives it its brown colour. I don't think iodine's soluble in water. Now, we're going to put the ions going across, and these ions are all they'll all be salts, stuff like sodium chloride, sodium bromide, sodium iodide, and all these are colourless solutions. I'll say they're all colourless solutions. So, when we've got chlorine reacting with bromine, now chlorine and bromide ions are both colourless solutions. Chlorine there, bromide ions there, they're both colourless solutions. But when it reacts, it forms bromine, and bromine is orange. So we can make a little note there that chlorine and bromide ions will give you an orange solution due to the formation of the orange bromine. Now, if we have a look at the rest of these, and we can ignore chlorine with chlorine and bromine with bromine and iodine with iodine. Chlorine and iodide ions, well, let's have a look. We've got Cl2 plus 2I minus. Can we predict will this reaction occur according to my statement highlighted? Well, chlorine here, Cl2, is a better oxidizing agent than iodine, so the chlorine will take the electrons off the iodine and give us the following. Now, again, we've got two colour solutions here, but we formed iodine, and iodine here is a brown solution. So my observation to show this reaction has occurred is you'd observe a brown solution forming. Okay, now let's see if we can predict what we would observe and even write an equation for the other reactions. Now, we'll go through these one at a time, and we'll have a look at these two, bromine and chloride ions. So let's just write these down. So I've got Br2 plus 2Cl minus. Again, according to my statement, will this reaction occur? Well, that reaction will occur if X2, in this case bromine, is a better oxidizing agent than chlorine. Well, it's not. Chlorine's a better oxidizing agent. So the bromine here cannot take the electrons off the chlorine. chlorine holds onto the electrons more tightly. So here you would observe no reaction, which I'll shorten to NR. So here you would observe no reaction. So let's now have a look at bromine and iodide ions. Just for the observation there, you would have an orange, it's quite a pale orange colour, and it wouldn't change. So if you add, for example, the colourless solution of chloride ions to bromine, it's orange, it will just stay the orange colour. So let's have a look at bromine plus iodide ions. And again, what we've got to look at is bromine, again, according to my statement, is bromine, Br2, a better oxidising agent than I2? Well, yes, it is, because the oxidising ability decreases down the group, so you would get a reaction where the bromine will take the electrons off the iodine, and you'll get 2Br minus plus I2. And again, we're starting really with an orange colour, and then that orange colour will darken to the brown solution due to the iodine forming. So here we would observe a brown solution. Now, the next two are both where we've got iodine as my oxidising agent, I2, so I2 plus 2Cl minus and I2 plus 2Br minus. I'm hoping by now you can see that the iodine is the weakest. This iodine here is the weakest oxidising agent. It's got the least ability to attract electrons. So when iodine wants to take electrons off the chlorine, it can't do it. When iodine wants to take electrons off the bromine, it can't do it either. So in both cases, you'd get no reaction. Well, let's complete the table. So I've got no reaction and no reaction. And that is a summary of the oxidising ability of the halogens.